Welcome to the final lesson of week 3 of computer science. In this lesson, we'll learn what pseudocode is and how to recognize code written in pseudocode. Pseudocode is used by programmers to communicate with each other when they're solving problems across different computer languages. So in this lesson, we'll recap what an algorithm is, and we'll look at how pseudocode is used to represent algorithms, some of the reasons why we might turn our algorithms into pseudocode, and we'll review some differences between the pseudocode used by the exam board and Python. So let's briefly recap what we know about algorithms. An algorithm sets out the steps to solve a problem. Specifically, it sets out the processing that has to take place to change the inputs that we start with into the outputs that we want to end up with. And the reason we might record an algorithm is to keep a record of our thinking, to check our work, or to share our ideas. Pseudocode is a way of setting out an algorithm using words, and here is an example. I've actually took this from Wikipedia, I think, and it just shows you what's happening within a program, but it's not computer code. You couldn't run it. But hopefully you can read that and see what's happening in that program. Another way of setting out the logic of a program is using a flowchart, and some of you will have used flowcharts before. I think flowcharts can be great, but they won't come up in the exam, and therefore I'm not really going to use flowcharts at all during this course. Using pseudocode as a way of setting out your thinking has several advantages. One is that pseudocode is language neutral, by which I mean that pseudocode should be written in a way that can be understood by programmers, whatever computer languages, programming languages they've learned. It should then be quite easy to convert pseudocode into lines of code in any language such as Python. Compared to a flowchart, a complicated algorithm takes up much less space if you write it in pseudocode. Pseudocode is used in a number of different ways to share ideas across different languages, to enable programmers to work in diverse teams with different language expertise, to keep a record of old ideas as languages change, and to convert a program from an obsolete language into a more modern language. But very importantly for us, the code in the exam will be written in pseudocode. You can see why. That's because in the different colleges and schools around Britain, people will be learning different programming languages. I think Python is the most common, but others will be used. Java is quite commonly used. So they have to write the exam questions using a style of code that will work for people with expertise in all different programming languages. So the code samples in the exam will be given in pseudocode, but you can give your answers either in pseudocode or in Python. And whatever you choose, you won't be marked on whether you've exactly met the standards of pseudocode. What it says in the marking advice is that as long as the code can be understood by any reasonably experienced programmer, then you should be given credit for your answer. So don't over stress about the details of pseudocode, but I am going to show you them now so that you can understand without too much stress exactly what the code is like in the exams. Pseudocode has many great similarities to Python. The use of expressions and operators is almost identical to Python. There'll be variables, the data types are the same, the input and output commands are the same, and the basic program structures are the same. There are some small detailed differences, and I'll go through those now. The operators are largely the same, but these 4 operators are different. Exponentiation, that is raising one number to the power of another, is shown as 2 stars in Python, and it's shown as a kind of up arrow, up arrow in pseudocode. Integer division, which is shown as 2 forward slashes in Python, is shown using the word div in pseudocode. I actually think that's a little bit easier to remember than the Python. It's divide, integer division, and remainder, also called mod, is actually the word mod in pseudocode. Not equal is shown in Python as an exclamation mark and an equal sign, but in pseudocode it's shown as 2 arrows. In the exam. In some other forms of pseudocode, you might see it shown as a crossed out equal sign. Comments in Python are shown with a hashtag, and in pseudocode they're shown with 2 forward slashes. I don't think that'll be too complicated for you. I don't think any of these differences will faze you in the exam. Conditional structures are slightly different, very slightly different in pseudocode. Instead of a colon, the header ends with the word then, and the structure is closed with the expression end if, sometimes written as a single word. In Python, of course, the bounds of the structure, the top and bottom of the structure, are marked by indentation. One advantage of using end if to show the end of the structure is it will still work if your layout is quite messy. So if you're quite a messy writer and you think it might be hard for the marker to see where your if statement ends, then end if is a good way of making that clear. The word elif in Python is written as else if in pseudocode. Again, I don't think that will really faze you. There is another conditional structure in pseudocode called switch. It doesn't come up very often, but let me just briefly review it. At the top of the switch statement, a variable or expression is given. And then in each of the cases, we give a different possible value for that variable or expression with following commands that might be carried out if that is true, and a default which is carried out if none of those cases are true. Fairly straightforward, unlikely to come up, but it could come up. Remember, there are 2 kinds of loops, counter-controlled and condition-controlled. The counter-controlled loop in pseudocode is very similar to in Python. The bottom of the loop is marked by next, the word next, and you may find that the counter works in a slightly different way. In Python, if we'd said range 10, it would count from 0 to 9, and in pseudocode it might count from 0 to 10. If you're in doubt about this or you want to clarify it, add a note or comment to your code in the exam. Condition-controlled loops are very, very similar to the while loop in Python. We've got the word do here instead of the colon, and the end of the loop is marked by end while. Once again, you do not have to follow all of this when you write your code in the exam. Just write your code clearly enough that any reasonably competent programmer can understand it. There is another form of condition-controlled loop, like the case statement. I haven't seen this come up very often, but I think you need to be aware of it. And this kind of loop begins with the word repeat on its own, and then the condition is at the bottom of the loop. The main difference here is that there's no need to set the condition before the loop begins, because the loop will be carried out at least once before you get to the test. So in some ways this is a simpler form of writing a loop. However, there isn't a repeat structure in Python. So to recap, we've just reviewed what an algorithm is and why we may use pseudocode to represent an algorithm. It has various benefits and uses compared to writing an algorithm in a programming language or writing it using a flowchart. And we've looked at the kind of pseudocode that will be used in the exam. This is the last lesson of the week, and so I'm not setting you any additional programming. You've already got programming tasks in hand. But get ready for the test next week, which will include algorithms written in pseudocode and revise everything we've done in weeks 1 through to 3. All right, so test next week. Bye for now.